Today, we're going to be learning about the quadratic formula. Our objective is that students will use the quadratic formula to solve quadratic equations. So if we graph the equation y equals 1/2 x plus 3 squared minus 4, let's see what our solutions would be. So y equals 1/2 x plus 3 squared minus 4. So there's our graph. And as you can see, our roots aren't quite on the whole number. It doesn't quite hit -6 and it doesn't quite hit 0. And if we hover over them on our Desmos calculator, we'll see that we get a decimal. So it's approximately -0.12 and -5.828. And we have approximately here because the decimals that Desmos gives us, even though Desmos stops after 3 decimal places, these numbers actually go on forever. So if we want to find the exact solutions, we will use the quadratic formula. So for a quadratic equation in standard form, which is ax squared plus bx plus c equals 0, the solutions would be x equals -b plus or minus the square root of b squared minus 4ac, and that entire thing gets divided by 2a. That's the formula we're going to use. Now, as we saw in the graph, we had 2 solutions. And this, to most people, doesn't look like 2 solutions. It just kind of looks like 1. Well, because it has the plus or minus in the formula, that's how we get our 2 solutions. One where we're adding the items in the numerator, and one where we're subtracting the items in the numerator. So let's try one. Solve 3x squared plus 20x plus 7 equals 0. So the nice thing about this equation is it's already set up for us. X squared's first, x is second, our constant is third, and it equals 0. So we're ready to start. So we're going to find a, b, and c. A is the number in front of x squared, b is the number in front of x, and c is our constant on the end. Notice how all 3 of those are just the numbers. The variables are not part of a, b, and c. To help make things easier, I'm going to start with the b squared minus 4ac part of the formula. It's the most complicated part. It's also called the discriminant, which you'll learn more about in Algebra 2. But it's going to help save us some work in the long run. So I'm going to take my numbers and plug them in. 20 squared minus 4 times 3 times 7. And I'm just going to type that into my calculator all at once, and I would get 316. So now I'm going to start plugging into the rest of my formula. So x equals -b, which will be -20, plus or minus the square root. Now it had the square root of b squared minus 4ac. We just calculated that part and found that it was 316. So I can just put 316 here. All over 2 times a, which was 3. So now we simplify. We need to simplify the square root, and we need to simplify 2 times 3. As we learned last class with simplifying radicals, we need to find the biggest perfect square that goes into 316, and in this case it is 4, and 316 is 4 times 79. So we're going to use the square root of each of those. So x will equal negative 20 plus or minus the square root of 4 is 2, and then we'll have the square root of 79, all over 2 times 3, which is 6. Now we need to see if we can simplify our fraction. And we're going to look at those three numbers, which I jokingly call the three Mouseketeers, because when you circle them, they kind of look like Mickey Mouse. And if you know the motto of the Three Musketeers, it's all for one and one for all. Either you can simplify all three of these numbers together, or you can't. If it's just two of them, you can't simplify, you'll leave it how it is. In this case, negative 20, 2, and 6 are all divisible by 2, so we can simplify. Negative 20 divided by 2 would be negative 10, plus or minus. 2 divided by 2 is 1, so we don't have to write it. And then 6 divided by 2 is 3. You won't change what's in the radical, just the number that comes outside. If we hadn't been able to simplify the square root of 316, if it had been like the square root of 13, we wouldn't have been able to simplify either. So that is our final answer. You can either leave it as x equals, or you can put your answer, that's terrible, in curly brackets. Either one of those is an acceptable way of writing your answer. Let's look at another example. Solve 2x squared minus 6 equals x. Well, to start off, this one does not equal 0, so we're going to have to change that. So I'm going to subtract x on both sides. And when I rewrite this left-hand side, I'm going to make sure I put the x squared term first, the x term second, and the constant third. It'll make it easier for me to see which is a, b, and c. So a equals 2, b equals negative 1, and c equals negative 6. So again, I'm going to plug into the b squared minus 4ac part of the equation, the formula first. So I'll have negative 1 squared minus 4 times 2 times negative 6. And when I type that into my calculator, I get 49. So plugging into the rest of the formula, x equals, the first part is negative b. So I would have negative 1, which would become positive 1, plus or minus the square root of 49 over 2 times 2. So now let's simplify. X equals 1 plus or minus the square root of 49 is 7, because it's a perfect square, over 2 times 2 is 4. And now you might notice that we don't have any square roots in our equation anymore. So we're going to be able to simplify this even more. I'm going to separate my plus and minus on the numerator. So I'll have 1 plus 7 over 4 and 1 minus 7 over 4. 1 plus 7 is 8 over 4. 1 minus 7 is negative 6 over 4. And those will simplify. 8 over 4 is 2. Negative 6 over 4 is negative 3 over 2. And those are my answers. We could write it that way, or we could put them in curly brackets. What if b squared minus 4ac is a negative number? That would mean we'd have the square root of negative something, let's say negative 4. You haven't learned how to square root a negative yet. Therefore, if you plug in b squared minus 4ac and you get a negative number, you can stop and just say no real solution. The most important part of this is that you say no real solutions. There is technically a solution or solutions, but they are complex or imaginary solutions. So for right now, we're just going to say no real solutions. That's all for today. See you in class.